When you first look at a mechanical drawing or hear engineers talk, it can feel like a secret code. Words like CAD, BOM, GD&T, FOS, OD all appear again and again. Have you ever asked yourself, what do these short forms really mean and how are they used in real design work? If you're a student, a fresher, or even a professional who wants clarity, this video is for you. Today we will go through the most common short forms used in mechanical design and engineering, one by one, with their full form and a real usage line. By the end, you will not only know what they mean, but you will also be able to read any drawing, talk with any engineer, and never feel lost in a discussion again. Let's begin. We start with the tools that shape how designs are made, stored, and checked. CAD means computer-aided design. Every 3D model or 2D drawing you create on softwares like AutoCAD or SolidWorks is CAD. CAM means computer-aided manufacturing. The same model is converted into a CNC program that makes the real part. CAE means computer-aided engineering. This is where you test your design on a computer for stress, heat, or motion before building it. BOM means bill of materials. It is simply the shopping list of every nut, bolt, and plate needed for a project. PLM means product lifecycle management. It connects every stage of a product's life, from idea to disposal, in one system. PDM means product data management. It stores your CAD files and revisions so no one uses an outdated drawing. ERP means enterprise resource planning. It connects departments like design, purchase, stores, and accounts in one platform. FEA means finite element analysis. You cut your model into tiny elements and check how stress spreads across the part. CFD means computational fluid dynamics. You check how air or liquid flows through your design. DFM means design for manufacturing. You keep the design easy and economical to make. DFA means design for assembly. You keep parts simple so workers can assemble them quickly. DFMEA means design failure mode and effects analysis. You predict where a design can fail and prevent it early. PFMEA means process failure mode and effects analysis. You check risks in the manufacturing process and fix them before mass production. Drawings are a universal language, and short forms make them clear and compact. GD&T means geometric dimensioning and tolerancing. You control shapes, positions, and tolerances with simple symbols. ISO means International Organization for Standardization. These are global rules that make drawings uniform. ASME means American Society of Mechanical Engineers. Many drawings follow ASME standards for clarity. ANSI means American National Standards Institute, used for American formats, threads, and fasteners. DIN means Deutsches Institut for Normung, German standards for components and tolerances. JIS means Japanese Industrial Standards, followed when parts come from Japan or Japanese suppliers. Psi is the symbol for diameter. When you see Psi 20, you know it's a 20 mm round hole. OD means outer diameter. For example, the shaft OD must fit inside the bearing. ID means inner diameter. For example, the pipe ID tells you how much fluid can pass through. THK means thickness. When a drawing says THK 8, you know the plate thickness is 8 mm. CSK means countersink. You drill a cone so the screw head sits flush. C-bore means counterbore. You drill a flat pocket so the screw head sits below the surface. HT means head. It tells you the shape of the screw top, like round head or countersunk. TYP means typical. If 4 holes are the same, the note says sight and typical instead of repeating. REF means reference. It is not for inspection, just for understanding. Now let's look at the materials we use and the processes that shape them. SS means stainless steel, used where rust resistance is needed. MS means mild steel, used for general purpose and structures. AL means aluminum, used when lightweight matters. PVC means polyvinyl chloride, common in pipes and plastic products. PP means polypropylene, used for containers and chemical resistance. HDPE means high-density polyethylene, used for strong and impact-resistant parts. CNC means computer numerical control, machines that follow programs to cut parts. Laser, light amplification by stimulated emission of radiation. Laser cutting makes fast and precise sheet profiles. AM means additive manufacturing, also called 3D printing, where parts are built layer by layer. RPM means revolutions per minute. It shows spindle or motor speed. HP means horsepower. It shows how much power a motor delivers. HVAC means heating, ventilation and air conditioning, used in buildings, cars and systems for airflow and temperature control. TIG means tungsten inert gas welding, used for clean and precise welds. MIG means metal inert gas welding, used for fast and strong welds on steel. Finally, let's see the short forms that decide if a design is safe, strong and reliable. FOS means factor of safety. It's the margin between working load and failure load. UTS means ultimate tensile strength, the maximum stress a material can take before breaking. YS means yield strength, the point where material bends permanently. NDT means non-destructive testing, methods like ultrasonic or X-ray to check defects without damaging the part. QA means quality assurance. It is the planned process to make sure quality is built into every step. QC means quality control. It is the checking of finished parts against drawings. MTBF means mean time between failures. It tells how long a machine usually runs before breaking down. MTTR means mean time to repair. It shows how quickly a broken machine can be fixed. PPAP means production part approval process. It is customer approval before mass production. CAPA means corrective and preventive action. It fixes defects and stops them from coming back. RNR means gauge repeatability and reproducibility. It checks if your measuring tools and operators are reliable. CPK means process capability index. It shows if the process stays within tolerance consistently. So now, when you hear words like CAD, BOM, OD, FOS or MTBF, you don't have to pause and guess. Each short form has a meaning and each meaning connects directly to real design work. This is why learning short forms is not about memorizing letters, but about speaking the real language of mechanical design. Keep this knowledge close. The next time you open a drawing, read a BOM, or stand near a CNC, you'll feel confident and clear. If you found this useful, share it with your friends because clarity in design helps everyone. And don't forget to subscribe to stay updated with more simple guides on design, software, and engineering. Until next time, keep learning, keep designing, and keep building with confidence.